Good morning, KM World. The Synaptica team and I are delighted to be with you today for this virtual event. Please come and visit us in the virtual exhibition hall to collect our downloads and chat about your projects. Today, I'm going to talk about building a knowledge enterprise, and I'll be joined a little later by Atanas Kyriakov, CEO of our close technology partner, Ontology. Synaptica's mission statement is really simple. We are here to help people organize, categorize, and discover enterprise knowledge. Synaptica has over 25 years' experience delivering award-winning enterprise taxonomy software and professional services to businesses and government agencies worldwide. Graphite, the tool we will be looking at in this talk, is currently being used by global brand businesses with applications as diverse as healthcare and life sciences, video gaming, travel and hospitality. So, what is a knowledge enterprise? There are 4 defining characteristics of a knowledge enterprise. 1. Knowledge is valued as a mission-critical asset. 2. Knowledge management, KM, principles guide the curation and sharing of tacit and tangible knowledge assets. 3. Knowledge organization systems, KOS, organize and categorize documents and data. And 4. Knowledge graphs, KGs, connect knowledge, data, and content to infer more knowledge. In this talk, we're going to explore the second 2 characteristics, COS and KGs. What is a knowledge organization system? KOS is a generic term embracing taxonomies, ontologies, classification schemes, name authorities, topic maps, and other structured terminologies. Many of these concepts overlap and relate to one another. So let's differentiate and clarify their meaning. A traditional view of the different types of COS was to chart them out on a line of increasing complexity. I have used something like this chart myself many times, but I've stopped doing that. It's time to turn this model on its head. From the semantic viewpoint, and by semantic I mean COS and knowledge graphs that are represented in RDF, ontologies and taxonomies are not things separated by complexity. Rather, they are integral components. An ontology is made up of 2 parts, a semantic schema and a taxonomy. The schema contains all the class types and property and relationship types. Think of it as the logical data model of the COS. The taxonomy is the set of specific concepts, classes and named individuals that populate the COS and are defined by the schema. By selecting class, property and relationship types from open data resources like SCOS, OWL, Dublin Core and PROV, we can quickly design semantic schema for any kind of COS, from the simplest glossary to the most complex ontology. Even a simple SCOS-based COS is actually an ontology comprising a schema and a taxonomy, which may leave you wondering when to call a COS a taxonomy or an ontology. The simplest answer lies in how you build hierarchies. If you build strict class-subclass inference-bearing hierarchies with OWL, then your COS will typically be referred to as an ontology. If you build non-transitive hierarchies with SCOS, which is widely adopted for topical and navigational taxonomies, then your COS will typically be referred to as a taxonomy. Graphite is Synaptica's enterprise taxonomy and ontology management solution. It lets enterprises collaborate to build any kind of COS, including OWL-based ontologies, SCOS-based taxonomies, hybrids, and custom schema. Step 1 of building a COS is to have a library of classes, properties, and relationship types. Graphite comes with a preloaded library, and it is easy to adopt or create add-ons. The second step is to design the specific schema for one or more cost schemes. Designing cost schemes in Graphite takes a few minutes with plug-and-play templates for common knowledge models. Graphite has ready-made templates for building taxonomies and ontologies, and add-on templates for managing governance and workflow, provenance, mapping crosswalks, or tagging. The third step to building a COS is to import any reference data. These may be RDF taxonomies, Excel files, or flat lists, and then to create concepts and classes, build drag-and-drop hierarchy structures, edit, review with stakeholders, and approve. Well, of course, it's actually a little bit more involved than that. Before you even start to build COS, there should be an enterprise discovery and analysis process that looks at business goals, content, metadata, tagging, and search. The flowchart on this slide depicts the process model used by Synaptica's Client Solutions team. After discovery and analysis, there are several blocks of activity to be managed, including modeling, collaboration, governance, development, and publishing. Let's take a quick look at some of the user experiences in Graphite. At the project level, we can visualize the entire schema of many cost systems that are interconnected. Here I'm looking at UNESCO, which is a United Nations multilingual taxonomy. This was available as public domain data in RDF and was simply imported straight into the Graphite system. Here we're looking at the tree structure in English, and we can dynamically change view language of the hierarchy into another language. Here we're going to select French. Very often we need to get data into a system from Excel. Here is an Excel file that has all of the typical elements of a taxonomy. This has got a 3-level hierarchy, it's got definitional notes, it's got synonyms, and it's got some related terms, some associative relationships. I've got a completely empty taxonomy here called My Taxonomy, and I'm going to drag and drop that Excel file into the taxonomy. The system analyzes the file contents, and then we can target which columns we want to put in which fields and properties of the taxonomy. So with those selections made, we import the data, and the Excel file has now become converted into an RDF graph taxonomy. We can expand and have a look at the different concepts in this taxonomy. We've got the hierarchical structure there. And if we're going to have a look at canines as an example, here you can see this concept has got narrower concepts and associated concept. It's got synonyms or alt labels and a definition. And all that came in from the import file. We can see here that grasses is in the wrong place, so simply dragging and dropping it in the tree structure relocates it in the hierarchy. We can also make associative relations hierarchically. So if we look at vets, we can see it's linked to canines but not to felines. Simply dragging felines over to the related container builds an associative relationship. We talked about building schemes in SCOS versus OWL and what are the merits of using strict class hierarchies. Here I've got a very small concept scheme that's represented in SCOS. So this is all SCOS, broad and narrower relationships to build the hierarchy. If we then go and have a look at this in OWL, we have exactly the same data represented in this OWL scheme, but here the hierarchy is built from OWL class-subclass relationships, and we also have named individuals as the leaf node concepts in this scheme. Let's look at visualization. So here we're looking at a concept carbon dioxide in the chemistry taxonomy, but it's got relationships out. This is a related match out to the GEMAT environmental sciences. So we can go from carbon dioxide to climate change mitigation to climate change and explore the graph. Taking another direction, we can go from carbon dioxide in My Taxonomy out to the UN taxonomy called UNESCO Thesaurus. Here we're exploring its relationships. You can quickly see that exploring graphs will open up a whole web of relationships. Our graph exploration filters let you dynamically filter the graph and pivot your view in mid-flow. So what we're doing here is I'm filtering the edges of the graph to only be certain kinds of edge types, and I can just click this and filter the view dynamically. I can now make a change where I go in and say I only want to see approved concepts in this view of the graph, and again filter the graph. There's a lot more I'd like to show you in the Graphite system, such as workflow management, the ability to create saved reports with lots and lots of criteria, management reports, exception reports, batch editing, but I just don't have time. So hopefully you'll connect with us and we can show you more of Graphite through one-to-one demos. What are enterprise knowledge graphs? So far, we have been looking at knowledge organization systems modeled in RDF and stored in a graph database. Just putting a KOS in a graph doesn't make an enterprise knowledge graph. KOS are formal systems for describing things, including documents and datasets. When we also bring the data and metadata that costs describe into the graph, then we have an enterprise knowledge graph. What makes an RDF knowledge graph so powerful is the formal semantics of the ontology schema support machine reasoning and analytics over the data and metadata. Likewise, the lexical semantics of the taxonomies in the COS support NLP, machine indexing, and content categorization. Enterprise knowledge graphs bring together two disciplines and skill sets, information science and data science. Every Graphite system ships with OntoText GraphDB embedded. The combination of Synaptica Graphite and OntoText GraphDB provide enterprises with an integrated suite of information science tools to create and manage the enterprise single source of truth for control vocabularies, taxonomies, and ontologies, and data science tools to perform data analytics, reconciliation, semantic search, and discovery. I'm now going to hand over to Atanas Kyriakov, CEO of our technology partner OntoText, who is going to continue the conversation about enterprise knowledge graphs.
Thank you, Dave. Knowledge graphs bring data and content together to enable better analysis and management. They allow better interpretation of the information by putting it in context, and they do so by linking enriched semantic metadata. OntoText platform makes knowledge management, data management, and analytics work in synergy. One can connect and publish complex enterprise knowledge. One can also customize and run analytics which link documents to taxonomies, extract new facts, classify and recommend content. Knowledge graphs have plenty of applications beyond content management. In enterprise data management, they enable unified data access, flexible data integration, and automation of various tasks. We summarize 20 years of our experience in a 10-step methodology on how to build, use, and evolve knowledge graphs. You can find this methodology presented in Synaptica's guide. We are very excited to partner with Synaptica. It's an honor for us that Synaptica integrated our GraphDB engine in Graphite. Thank you, Dave. Over to you.
Thanks, Atanas, and thank you for attending our talk. 15 minutes is only enough time to cover a few highlights, so please reach out to us to carry on the conversation. OntoText and Synaptica issued a press release this morning with news about how we are working together. Visit our booth or website to download the press release as well as the Synaptica 30-page guide to developing enterprise ontologies, taxonomies, and knowledge graphs.